What I want to do is really focus on two main things. Why is this topic important? And what do you need to know? So the first one, why is it important? So understanding variable types are critical. They're important for helping you to understand your research question. That's going to help you in your stats courses. And it's also ultimately going to help you when you get to your dissertation if you're going that track, and really helping you figure out not only what variables will you use, but how are you going to collect those variables so that you have them in the right format, so that you have the right statistical test available to you. This is a very ugly looking slide, but it's incredibly informative. And what it does is it can kind of help you walk through. The purpose of this slide is really to figure out what statistical test you're using. So are you doing descriptive statistics? Are you testing for differences? Or are you testing for relationships? But as you walk through this slide from the left to the right, the decisions a lot of times are based on the types of variables that you have. Are they continuous or are they categorical? If they're categorical, are they nominal or are they ordinal? And there's some important differences which we'll discuss. Sometimes you won't even have categorical, you'll have frequency data, just numbers, and you'll be using other types of tests. So again, it's good to get your hands on a table like this as you're starting to try to figure out how to decide what statistical test to use. And then finally, what do you need to know? Well, you need to know the key terminology. If you know and understand the terminology, then it's going to start making more sense. Not only the variable types, but literally, is this the dependent or independent variable? Now, I'd like to, normally when I try to figure things out, I categorize things and I put decision rules in my head to say, okay, so the continuous are the ones with the numbers, and the categorical are the ones with the names. Unfortunately, it's not always that straightforward, and I'll show you how that works in a moment. The other thing is, even when I started tutoring, I frequently have a mental block in really figuring out what was the dependent and what was the independent variable. Again, to be successful in statistics, these are things you just need to know. And that might mean you have to read it several times, or watch several videos, or participate in webinars such as these. But eventually, the more you do it, the more comfortable you're going to get with this. And let me give you an example. Okay, so I'm a public health guy, so we frequently use, so I use public health examples. Here's an example, the body mass index. This body mass index can actually be measured and put into several different types of variables. So the body mass index, for those of you that don't know, it's a ratio of your height and your weight. It's converted to the metric system, so it's kilograms over meters squared. So that number can be expressed as a continuous variable. And what I mean by that is it typically, a normal range is between for someone who's not overweight, it's between about 18 and 25. Between 25 and 30 is considered overweight, and over 30 is considered obese. So you would have a continuous number that would fall within that range of numbers. So that defines really what a continuous variable is. It can also be expressed, however, as a categorical variable. So for example, you might use ranges like the one I just used, like 18 to 25, 25 to 30, greater than 30. That would actually be what's called an ordinal value, meaning that it's an ordered set. It's a logical sequence from lowest to highest. You can also express them as names, so normal weight, overweight, and obese. Okay, so those are examples of a categorical that's an ordinal value. Sometimes categorical values, instead of being ordinal, they're nominal. Ethnicity would be an example. So black, white, Hispanic, Asian. There's no order to that. No one of those categories has a higher point value than the other. With body mass index, you can also express as the individual components, so the height and the weight separately, again, as continuous variables. So, and again, it's also expressed converting to actually another measurement system. So it's an example of a kind of complicated variable. And if you were doing a test, maybe your dissertation, and you wanted your body mass index to be one of your variables, then you would need to put some thought into, okay, how do I need to collect that? Does that need to be a continuous, or does that need to be a categorical variable? So again, they're measured two ways, or two types. The first one, think of it as being measurement related. So think of intervals. Think of integers. So it doesn't have to be completely continuous, like it can be 1, 2, 3, 4, 5. So they're discrete numbers, but they're based on a value. They're based on something that's being measured. Continuous, again, think of it as something within a full range of numbers. If it's a categorical variable, then the three options are dichotomous, which also means binary or binomial. It just means there's two options. So gender is a categorical variable. There's only male and female. There's nominal, think names here. And again, I use race or ethnicity as an example here. And then finally ordinal, so think of scales. You also get into what's called whether it's discrete or continuous. So just discrete variables are observations that cannot continually be refined into a smaller number. So these tend to be, so if you have a discrete, it may be a categorical variable. So a dichotomous, a nominal, and an ordinal are all discrete. You can't break down those variables into smaller and smaller units. Continuous variables are ones that can be broken down into smaller units. So they're mostly interval or ratios. So an example, a distance could be measured in feet or inches or even smaller units. So you can select the unit and then scale it based on that. So let me show you some things that can be confusing then. Here's an example from a data set. So we have, going from left to right, we have a record number, we have gender, we have age, weight, ethnicity, and education. Okay, the record number is just simply the number of the record. And again, it's just simply an identifier. That's all that variable is. Gender in this case is being coded. I'm guessing typically it's 1 equals male, 2 equals female. So again, don't be confused and think that that's a continuous variable. There's no value that they're not representing like the 2 is greater than 1. It's just simply a way to code the variables. Age is a continuous variable. You can have, many numbers within a range. These tend to be integers. You typically don't break age down into smaller units. Weight, the next one, is also continuous. It's possible to break weight down. You might have it, out to a couple of decimal places, for example. But those would both be examples of good continuous variables. Ethnicity, it's the same as the gender, except that it's not binary, but it's still nominal. Again, it may be 1 for white, 2 for black, 3 for Hispanic. And so, again, those numbers are just simply codes. So you would never want to run like a mean and a standard deviation on those. It wouldn't make any sense. And then finally, the education is an ordinal value. Again, assuming that the lowest numbers have the least amount of education and the highest numbers have the highest amount of education. So here's just another example in a data set, basically showing the same thing. The column I have highlighted, again, you can code it in a database as a name or a number. Typically, the reason that we typically use numbers is it's just cleaner and easier, less problem prone for like typographical errors. So that's why we use that. If you're familiar with SPSS, this is an example from the data view in SPSS. And again, you can see it's a little bit, I'm sure, a little bit tiny on your screen. You can see where those, even like that blood pressure class that was coded in blue here, has now been converted to a number. So ones and twos. And all of those variables have been, so basically everything in this data set is a number. That does not mean that all of these variables are continuous. When you get to the variable view in SPSS, you can actually define your variables. You can create the values, you can put the labels in, but what's important for the variables is the type of variable, and again, it can be numeric. In this case, I have ethnicity coded as numbers. 1 equals white, 2 equals black. So I'm using a numeric function that does not, but again, the variable is a nominal variable when you get to the measure column. That's what that does. What you do then is, once you figured out your variables, then how do you relate that to your statistical tests? You have to know the requirements for each of your statistical tests. You also have to know which was the dependent and which was the independent variable. And ultimately, you need to know how your data was collected. So the dependent variable is the outcome that you're studying, while the independent variable is the intervention that's taking place. So a couple of examples here. I'm doing a study of exercise and fitness. So my exercise program is my independent variable, and my level of fitness is my dependent variable. If I have a diet to promote weight loss, the diet itself is the independent, and the weight loss, maybe in pounds, that would be my dependent. I'm looking at the effect of sodium intake on blood pressure. So I have sodium intake as my independent, and blood pressure as my dependent variable. So again, not enough time to go through all of these tests, but basically Ttest and ANOVA, I want to point those out. The requirement for both of those is that the dependent variable be continuous, and that the independent variables are categorical. And in fact, in a t-test, they're binary, meaning only two options. In an ANOVA, you can have more than 2 options. In correlation and regression, you're typically working, if you're using linear regression and linear correlation, you're typically working with continuous variables. If you get into categorical variables, there's another type called logistic regression. Our colleague, Dr. Xin Tui, has done several sessions, and I think a couple more to come, on logistic regression. So I'd refer you to that. Chi-square uses rates or frequencies, so like the number of people in each group. And then, of course, the graphs themselves have different types of requirements based on the type of graph and the type of data. So again, with descriptive statistics, if you're using continuous variables, then you'll use things like mean and standard deviation. If you're using categorical variables, then you're going to run a frequency table. And again, the graph, again, it's based on the type of graph that's being used. So in summary, you need to know the types of variables that you'll be using in your research or in your assignment. Make sure that these variables can be used in a statistical test that you've selected to answer your research question. And when in doubt, seek help from your chair, your committee member, your professor, or your tutor.